Okay, so equations for these chemical reactions. Chemical change occurs when a substance is converted into one or more new substances that have different formulas and therefore different properties. So what we're going to learn for this one is how to write these balanced chemical equations from the formulas of the reactants and products for a reaction, and also determine the number of atoms in the reactants and products. So this is kind of building on what we did last week and applying it to this new concept. So we've talked about different chemical changes before in, I think it was the first or the second lecture. So a chemical change is, it occurs when a substance is converted into one or more substances with different formulas and different properties. They may be observed by the formation of bubbles, a change in color, the production of a solid, or a heat that's produced or absorbed. And so one example here is rusty nails. Okay, so the chemical reactions involve chemical changes. When the iron reacts with oxygen, and then the product would be rust. So what would that equation be? So one example would be you have carbon and oxygen, and when it comes together, it gives you coal. Okay, so obviously very different from carbon or oxygen when you put it together and you make coal. So what are the symbols used in these chemical equations? Well, to write a chemical equation, we're going to have an arrow that's going to separate the reactants or the starting materials from the products or the end materials. The reactants are written on the left side of the arrow and the products are going to be on the right side of the arrow. And there are multiple reactants or products that are separated by a plus sign. The delta sign indicates heat is used to start the reaction. So if we have reactant plus reactant, over the arrow we have heat, this would end up producing a product plus a product. And the physical states of compound are denoted in parentheses following the compound. So solid is an S, liquid is an L, G is a gas, and aqueous or dissolved in water is a Q. So here's your handy dandy little table that you can keep by your side. So how are we going to identify a balanced reaction? Because remember, everything in chemistry has to be balanced. So in a balanced chemical equation, no atoms are going to be lost or gained. And the number of atoms on the reactant side is going to be equal to the number of atoms on the product side for each of the elements. So you can see that we have one carbon on the reactant side and two oxygens on the reactant side. And then again on the end or the product sides, we have the same one carbon and two oxygens. So we're just transferring them, right? We're not creating or destroying, and we have to equate them all out and they have to be the same. So here's our handy dandy little guide. We're going to balance a chemical reaction by writing an equation using the correct formulas for the reactants and the products. Count the atoms in each element of the reactants and products, and then use coefficients to balance each element. Like I said before, if we have two carbons on the left side, we're going to have to end up having two on the right side. And then we're going to check the final equation to confirm that it is balanced. So let's practice by balancing chemical reaction or equation for the formation of Al2S3. So write the equation using the correct formulas of the reactants and products. We have aluminum, solid, sulfur, solid. We're going to do the reaction and we're going to get, again, a solid. And so that would be the step one and write it out. Now let's balance. We have to count the atoms in each element for the reactants and products to make sure that they're the same. So on the left, we have one aluminum and one sulfur. And in the products, though, we have two aluminums and three sulfurs. So that's definitely unbalanced. So now let's work to balance them. Let's use these coefficients like we did before. So if we had two aluminums over here, we're going to have two on the starting side. We have three on the reactants or the product side, we're going to have three on the starting side. Okay, so now when we check the final equation to confirm that it's balanced, we're going to have two atoms of aluminum in the reactants and two atoms of aluminum in the products. 3 atoms of sulfur on the reactants and 3 atoms of sulfur on the products. And so this is now balanced. So let's practice. Let's state the number of atoms in each element on the reactant side and the product side for each of the following balanced reactions. My cat's meowing. Sophie. All right. So what do we have? So for P, we have on the reactant side 4, and on the product side 4, because this 4 means that there's 4 PBr3s. Okay, so there's 4 P's, 4 Br times 3, so that would be the 12. Okay, so I'm getting a little bit ahead of myself. So we have 4 P's and 4 P's, so we're balanced. So if we have 6, never mind 2's, right, then that would give us 12. So 6 times 2 is 12. And then again, we go over here, we have 3 times 4, and that gives us 12. So that is balanced. So we can see that, again, if we do it with this, we have 2 aluminums, right? Al2, so there's your 2. We have 2 Fe. We have 2 Fe in the solid state. We have 3 oxygens, and we have 3 oxygens. So you can see that now they're all balanced. So let's practice. Balance the chemical equation when a solid Fe3O4 reacts with a hydrogen gas to produce a solid iron and water. Okay, so what are we going to do? Well, let's write out the equation first. So we have Fe3O4, that's a solid, okay, because it told us it was a solid, and it's going to react with hydrogen gas. So we're going to put the hydrogen there, and remember H2 makes it stable, and it's a gas. And then we have the reaction, and it is going to produce a solid iron here and water. So water is a liquid. Okay, so now let's balance. So when we look at counting the number of atoms in each element in the reactants and products, the atoms of Fe, we have 3 for the reactants and only 1 for the product. 4 oxygens for reactant, 1 for the product. 2 hydrogens for reactants, 2 for the products. So it looks like hydrogens are balanced, but these other guys need a little bit of work. Okay, so what are we going to do? Well, let's balance them. So we have 3 to 3. Okay, so if we ended up knowing that we have 3 over here on the reactant side, we know that we're going to end up having 3 on the product side. So that's how we got that. Okay, and then the oxygen we have 4, and then we end up having 4 over here, because remember this means 4 H2Os, so that would be 4 oxygens, 8 hydrogens, and then they're balanced. All right, so good job. So now we are balanced. All right, good job.